Hello everyone, how are you? We will discuss in this video the most important ideas that we have made last week. We discussed how to write complex numbers in trigonometric form in different situations. We know how to find it in trigonometric form. We find first the modulus and then the argument if it's given the algebraic form. But in this case, for special cases in different situations, we mean it will be given in different way, but you should use some trigonometric formulas like sine minus theta equal minus sine theta, sine minus theta equal cosine theta, tangent minus theta equal negative tangent theta, sine pi minus theta equal minus cosine theta, sine pi minus theta equal sine theta. This is useful. And cosine pi over 2 minus theta is equals to sine theta. Sine pi over 2 minus theta equals to cosine theta. They are useful to change from sine into cosine or from cosine into sine in some situations or different situations. In the second lecture, we said that the exponential form of a complex number is the same as trigonometric form, including the modulus and the angle, but it's written in different way, like r, e, I, theta. R is the modulus, e comes from the exponential form, I is the imaginary number I, and theta is the argument of the angle, which is equal r into cosine theta plus I sine theta. For example, if we have I, the complex number I, we know that its argument is pi over 2 and its modulus is 1, so it's written like that. ei pi over 2 minus I is written e minus I pi over 2, not because it's minus I, because the argument is minus pi over 2. 1, it is ei 0, since the argument of 1 is 0 and its modulus is 1. Minus 1 is also, its modulus is 1, but it's ei pi. Properties: if two complex numbers are equal, then r prime I theta prime equal r e I theta. So it means that r equal r prime and theta equal theta prime, just comparison. The comparison between two complex numbers, it means that they are equal, so it means the radii, the modulus are equal, and the angles are equal. The conjugate of the complex number re I theta is re minus I theta. The opposite, which is minus z, it means if we have z equal rei theta, then the opposite is rei theta plus pi. If we multiply two complex numbers, we multiply the moduli together, and we add the angles together. 1 over rei theta, we keep r the denominator since it is a modulus, it's a number, but ei theta, we just take it up to the numerator with minus I theta. Just flip the sign. Rei theta over r prime ei theta prime equal r over r prime ei theta minus theta prime. Just subtract the angles. And we said you can just work with this as powers. It's not a power. I theta is not a power, but you can work and just to memorize them. You can work like powers. Rei theta power n equal r power n ei n theta, n times theta, where n is a integer belongs to z. This was everything. Thank you so much.